Good evening. Today we are going to talk about operating systems, and this is the lecture 1 of the operating system concepts lecture series. I believe that you are already familiar with these terms. Let's look at what is hardware. All the physical components, including electronic, mechanical and optical devices, are called hardware. And liveware is the computer uses. The operator of the computer system is called liveware. Today our focus is on software. So software means programs. Software saved on storage media. Some of the software burned into hardware, so in that case they are called firmware. So our software is categorized like this. Software can be categorized into two groups: application software as well as system software. What are application softwares? Okay, let's say we are preparing a document. In that case, you may use MS Word like software. So that is an application software. To prepare this presentation, I used MS PowerPoint. So MS PowerPoint is also an application software. So then the system software is categorized into two different groups. First one is utilities and the other one is operating systems. Utilities are the tools that we can use for maintenance of operating system. For example, defragment tools, virus guards, some other malware detection tools like that. Operating system is our concern during this whole lecture series. Okay. Now we can extend our previous categories like this. So the bottom layer is hardware. So the topmost layer is users. In between we have software layer. Further we can divide that into two layers. The bottom layer is operating systems and the top layer is applications and utilities. Okay. So what is an operating system? So the definition of an operating system, we can define an operating system as an interface between users and the hardware. So the operating system acts as an interface between users and hardware. On the other hand, someone can say operating system is a collection of software that manage computer hardware resources and provide common services for other software. So there's plenty of examples in the industry. The most famous one around the Asian countries is MS Windows. Then we have Ubuntu, Fedora, Solaris, Chromium OS, CentOS. Lots of operating systems are there. These are the services provided by an OS. Process management. Let's say I'm typing a document. In that case, I may be using a software like MS Word. In that case, MS Word is a process. Let's say I'm preparing a PowerPoint presentation. In that case, I may be using MS PowerPoint. In that case, PowerPoint is a process. So when we are using different processes, we have to manage them. That management is also done by operating system. Then we have to save those files. In that case, storage has to be managed. So that is automatically done by the operating systems. When we are running different programs, we have to keep all those programs in the memory. In that case, memory should be managed. So that is also done by memory. And to use different input devices and to get something out of the system as an output, we have to manage input output devices. That is also done by the operating system. The most important one here is the user interface. So operating system provides an interface between the user and the hardware, and the security is another concern. One other thing is error detection and providing necessary responses. And operating system is responsible for monitoring performance as well. Those are the duties of an operating system. Then we are going to talk about evolution of operating system. So to talk about evolution of operating system, we have to go back to 1940s. It starts with serial processing. Let's look at what is a serial processing. What is a serial process? Serial means one after other. There's a sequence, a proper sequence, one after other. In this type of operating systems, actually there were no operating systems at all. So the operator here, as you can see in these pictures, there's an operator. He's the one who is operating the computer. So he's the one who interacts with the hardware using this special panel called a console. So this console has some lights, special switches, toggle switches, some input devices, and maybe some output devices as well. So this serial processing system, it's a single user system. At a particular given time, we can only have a single user for that system. So there were no operating system. The main disadvantage of this system is we have to use a hard copy for preserving time. These days we have computers everywhere, but at that time it was not like that. The very first thing that they have to do is find a place where we have a computer. Then we have to reserve a time slot. Let's say a user reserves a time slot of 30 minutes. Okay. Sometimes user may not be able to finish within that 30 minutes. In that case, he has to reserve another time slot and restart everything from the beginning. That's the main disadvantage of serial processing. To overcome this issue, simple batch processing systems were introduced. Users may have different jobs, so users program those jobs into a punch card or a magnetic tapes. Then they are handovering those tapes or punch cards to the operator, and operator batch those jobs into several groups. For example, job 7, job 5 and job 2 is a single batch, and job 4 and job 1 is another single batch. So they were grouped together by the language they have used. So when when we want to execute a particular job, it's not a job that we pass to the CPU. It's a complete batch that we are passing. One other thing about this system is special software called monitor is introduced in this simple batch processing system. The monitor is a special software component which resides always in the memory. Its duty is to sequence the jobs. And other important thing is interrupts were introduced with this system. So user can submit jobs to a computer operator, then operator batch group several jobs, then they were passed to the CPU. There's a special program called monitor is there. It always resides in memory, so we have to allocate some amount of memory for that as well. Okay, so these are the disadvantages of simple batch processing system. As I said before, there's a special program called monitor is there, so we have to allocate some amount of memory for the monitor as well. And one other thing is, since it is also a program, it consumes some processing power of the CPU as well. That is also a disadvantage. And the advantage of this simple batch processing system is it reduces setup time. Okay. Then we are going to talk about multi-program batch system. So what is a multi-program system? Multi-program means running multiple programs at the same time. The example that is given here, there we have Firefox, Word and a Java program running simultaneously. So to run them at the same time, the CPU should be shared among these processors. That is called transfer of control. Transfer of control is called a context switch. In this example, at first the CPU executes some codes of Firefox. Then a context switching is happened, and then CPU executes the word process. After a certain amount of time, another transfer of control or a context switching is happened, and the transfer is given to the Java program. Then CPU execute that Java program. Again, it transfer the control, then some other program may be executed. Okay, here is a detailed explanation about multi-program batch system. If we consider only about a particular program, let's say program A, it may be runs for a let's say for a given time. Then that process may want to execute some IO operations. In that case, CPU has to wait until the IO operation is done. So after the IO operation, then the program A again starts to execute. Let's say program A wants to do some IO operations again. In that case, CPU is waiting until the IO operation is done. Likewise, program B is also there. Program C is also there. So if we switch between these processors and execute them like this. Program A, program B and program C, all of them are combined together and execute like this. In that case, we can reduce the waiting time of the processor, waiting time of the CPU. Here we are executing process A, program A. Here we are executing program B after the program A, and once it is completed, then we are executing the program C. Then we can reduce the idle time of the processor. So this is an advantage of a multi-program batch system. So this is the central theme of most of the modern operating systems. Windows is also based on this idea. So this will reduce the idle time during I/O operations. And since we are running program A, program B and program C simultaneously, we have to keep all of these programs in the memory as well. In that case, memory has to be partitioned to hold all those programs. Then we have time sharing system. The idea of time sharing system is the processor's time is shared among multiple users. In previous multi-program batch system, we shared the processor among multiple processors, but in time sharing systems, we are sharing processor's time among multiple users. So multiple users simultaneously can access the system through their terminals. Then we are going to talk about different type of operating system based on the users and the tasks. So we have single user, single task kind of operating system. That means in a particular time there we can have only single user, and on the other hand that single user can perform only one task simultaneously. Example for this type of operating system is MS-DOS. Only one user can log into a MS-DOS operating system and perform only one single task at a given particular time. Then we have single user multitask. It's like Windows operating system. Only a single user can use that operating system at a given particular time. He can perform multiple tasks. Then we have multi-user multitask, which means several users can log into the operating system simultaneously and they can run many programs simultaneously. Then we have a multi-threading operating system. Thread is a very smart concept. As I said before, when we are preparing a document, we are using a software like MS Word. In that case, MS Word is a process. I told you that. In threading, we can divide that process into sub-processes. It's not like a sub-process, but we can consider that as a sub-process. So we can divide processes into sub-processes, and each and every that sub-process is called a thread. So we can divide processes into sub-processes and run them as a separate process. So that is called multi-threading. So threads provide way to improve application performance through the parallel execution of sub-processes, threads. Then we have real-time systems. We are using real-time operating systems in a places where we need very precise timing and with a high degree of reliability. For example, ABS brake system uses this type of real-time system. And then we have time sharing system. Time sharing system means processor's time is shared among multiple users or multiple applications. So processor switch among multiple users or multiple applications to provide execution time for them. So that's the idea of different types of operating systems. So today we talk about the classification, then we have identified a proper definition for an operating system. Then we have identified different operating systems. Then we have identified the services provided by an OS. Then we talk about evolution of operating systems. And finally, we talk about different type of operating systems. So that's it for today. So go through this lesson, and if you have any questions, ask them at the discussion time. So have a nice day and prepare for the discussion. Thank you very much.